Well, hello, everybody. Welcome to Master the NEC, where we talk about the National Electrical Code, sponsored by Electrical Code Academy Incorporated. Hi, my name is Paul, and on today's PaulCAST, we are going to talk about the necessary tables and the beginnings of what you need as a kind of a preamble to sizing raceways for use in conductors, to how many conductors I can put in a raceway and all those. And so we're going to talk about the different tables that you got to be familiar with. And this is kind of, again, a preamble to a webinar that I'm going to be doing here shortly. We're working on all the graphics for that right now. But so I should give a shout out. If you don't know how to do adjustment and corrections, then we have that video that's out on our website. Again, that is masterthenec.com, masterthenec.com, .net or .org. Or you guess you could go to mastering at masteringthenec.com and you'll get to us there as well. We have tons of websites. You can go to electricalseminars.net and get there. Gosh, there's just tons of them. But anyway, so this is kind of for those that are maybe the apprentices and you're getting ready to sit down with your book that you're going to use to take your exam, your prep course, and you're saying, okay, what are the basics that I need to know about raceway fill? Making sure that I don't exceed the actual fill requirements that are for a raceway. So, and in some cases, raceways and tubings and what have you. So the good news is, look, if you're using an MC cable or something like that where the conductor's already in it, then you don't have to worry about it. But if you're using a tubing or a conduit system, both of which are raceways, then you're probably going to be limited to how much space that you can actually, or area that you can take up inside of that wiring method. And granted, there is also a video that we'll be doing, as well as and that will probably be a video because it's really hard to do a PaulCAST or a podcast on the wireways and gutter fill requirements. So we'll do that separately. So really what this primer here is for is to get you ready for that course that we're going to offer. And it kind of shows you exam prep on how to do a raceway fill. So we're just going to tell you in this video, or I keep saying video, we're going to tell you in this PaulCAST or podcast. I refer to them as PaulCAST because I'm the one doing it. And people will say, wow, that's very conceited of Paul. And yep, you're right. It is. Get over it. All right. So here's the thing. You got to know a couple tables in order to be able to do this properly. So the first thing I want to cover is, what are your raceway fill requirements? So if you have your code book, and we're doing the 2017 edition here, but this works for the 14, 11, and 8, and 5. All of that didn't change. First thing you need to do is you need to go to Chapter 9, which it's a tables. And we're looking at table number 1. Now, table number 1 says the percentage of cross-section of conduit and tubing for conductors and cables. So that means even the application where I might put a cable assembly inside of a conduit or tubing. And that can be done. And many times you can do that. In fact, there's a provision for non-metallic sheath cable in Type 1, Type 2 construction to actually put it inside of a raceway system that is capable of being installed in a Type 1, Type 2 construction, this concrete and steel construction, where normally you wouldn't use non-metallic sheath cable. But it does give you this allowance. And again, don't want to go down that path, but I'm saying there is applications where I can put a cable assembly inside a conduit or tubing. Keep in mind that you have different items here. These are notes to the table, and all of these notes are very much applicable. Means they have to apply. Now, the two important notes that I'll remind you is that note number 2 says that table 1, and we're going to talk about table 1 in a second. It says table 1 applies only to a complete conduit or tubing system. Not one that's being used for physical damage protection, but really it starts from one box to another or from a panel to a box. It's really a complete system. And for some reason, you're putting a cable assembly, let's say, inside of that. All right? Because generally, if you have a wiring method that's going to run individual conductors, then it's going to be a complete system. So Table 1 that we're going to talk about here really only applies when it's a totally complete system. Okay, so that's the first thing to remember. If it's a short piece for physical protection of something as it penetrates a floor or does something else, then these percentage fill requirements don't apply here. Okay, so Table 1 tells me, look, the number of conductors and or cables. If I have one conductor or one cable, I'm going to treat it as a 53% cross-sectional area that I can't exceed. So 53% of that cross-sectional area of that raceway, I cannot exceed. All right, now if I have two conductors or two cables, I can't exceed more than 31% of that cross-sectional area. And if I have anything over 2, then I can't exceed 40% of that cross-sectional area. Okay, before you get confused and say, wow, how do I do that? You're going to learn that in the exam prep, and you're going to learn that if you're in some kind of course where you start going over. What we want to do here is just kind of get you familiar with the different tables that you're going to have to utilize. So the first table is Table 1 because you need to know what that fill requirement is or what that cross-sectional area in a percentage that you can't exceed. Now, if it is, and we're going to deal with over 2 because that is general one you're going to find. You're going to usually have more than 2 in any raceway, any complete system. And that would mean that you can't be more than 40% fill. But just to throw it out there, if you happen to have like we said, NMB, a non-metallic sheath cable, type NMB, some manufacturer will refer to it as a Romex. Others don't. It's just type NMB. That's the real technical name for it, non-metallic sheath cable. Then you want to put that in a complete raceway system. Then you have to come down and look at item or what we call note to tables, which is 9. Now, note 9 says a multi-conductor cable, obviously is more than one, it's multi-conductors, states that for cables that have an elliptical cross-section, and that's what you have with an NMB, for example, you have a wider than the thickness versus the width. Because it's flat and wide. If that's the case, you want to take the wide or the major diameter of the ellipse, which is the wider of the two, and you do that. And if it's a circle, it's just like an SER cable, then you just treat that as a round conductor and you get your diameters. You can get that from the manufacturer if you need to do that. And it usually is on all their cut sheets. And you can even get the elliptical or the widest portion of a flat cable from the manufacturer as well. Just go to their cut sheets and they'll usually give you the dimensions for that, and that's what you'd use. And incidentally, if you don't know how to do all that, we have some graphics out there on that. I even have some blogs that explain how to do that calculation. And maybe I'll do that in an upcoming video. Because I already have the graphics for it, and I'll be more than happy to show you how to do that. Also, if you connect with me on LinkedIn, I have an actual article on there that explains all the aspects. So go to LinkedIn and look for Paul Abernathy, and you'll find my article on there, and you can read that article. It's got graphics in it, and I show you how to do all that. But anyway, we're trying to find out the fill. So if it's just one cable and I put it in here, I have to make sure that I don't exceed 53%. It's pretty simple, right? And it tells me, and it also reminds you to say, look, a cable is not, if you take individual conductors and you twist them together, they're still individual conductors, okay? But when it is actually a cable that is listed, like an NMB would be, or an MC would be, or whatnot, that goes into a cable, then you can treat it at the 53. If you use individual conductors that somebody just, quote, plexed them together or twisted them together, then the code made it clear in the 2017 cycle that when you do that, you don't get any advantage of using the 53% or whatnot. You got to treat it as multiple conductors, and you have to treat it in over 2, so it's got to meet the 40%. It can't exceed the 40% cross-sectional area requirement of Table 1, okay? Just want to throw that out there. So that you're all aware of that. So that's what we're talking about. So Table 1 is going to give us the parameters when it comes to not exceeding the percentage of cross-section inside a conduit or tubing. That's the first table you got to be familiar with because you got to know. Just remember, if it's over 2, you're going to limit it to 40. If it's a cable assembly like a tray cable or NMB, UF cable, then you treat it, if there's only one in there, you treat it at 53%. You're hardly ever going to use the one where you have 2 conductors or 2 cables of the 31%. But in case you do, just need to know that Table 1 is what you got to be at. Now, What if all of the conductors that are installed in a conduit and tube were the same size? In other words, you don't have an equipment ground conductor that's smaller. Your neutrals and your all of your conductor, everything is the same size. Well, then it's simple. Then you can go to what's called Informative Annex C. And under Informative Annex C, you're going to see that you have EMT, FMC, IMC, LFNC, LFMC, all of these types of RMC, which is rigid metal conduit, liquid tight flexible metal conduit, LFMC, even rigid polyvinyl chloride, Schedule 80 and Schedule 40. You're going to see a whole list of these tables. And in these tables, it's going to flat out tell you, depend on the size, how many conductors that you can have of that type of insulation to conductor inside of that conduit or tubing. Keeping in mind that that only has to do with the number of conductors. Okay? That doesn't have anything to do with the total ampacity that you're going to have if you exceed more than 3 current carrying conductors in a raceway or tubing. To do that, you need to know how to do adjustment and corrections. And have no fear, we have a video on that. And there's a detailed 2.5-hour video that's available on our website. Doesn't cost you a dime. You can get it on our YouTube channel as well. Just go to YouTube and search for Master the NEC, and you'll find it. And I walk you through the entire process of how to do adjustment and corrections. That's a total different thing. Here we're just talking about a sheer question. So if you're taking an exam and it wanted to know how many 500 kc mils of let's say THHN that you can install in let's say an EMT, how many can you install of 500 kc mil THHNs in a raceway? What size raceway? Well, you got to know something from the test. But if it's 500 kc mil, you go down, it's table C.1, and you look for THHN on the left, you come over to the right, you find the 500, and you say, okay, well, what size of raceway we're talking about? If it is a trade size 2.5, then I can have 3 of them in there. And that tells me if I have 3, I'm not going to exceed the 40% fill. Okay. So that's what we do here. If it is a trade size 3, I could have 5 of them there. So this table works great if you're just trying to find out how many conductors go inside of a certain type of raceway or conduit system or tubing system, all of those which are raceways. And as long as you know the insulation type and you know the conductor size, you can go right here. If that's all the question is asking you on an exam, then there's your answer. Now, you want a more accurate way to do this when you have when all of the conductors inside of the raceway system are not not all the same. Well, then you got to do something else. So that was the easy route. Okay. And that might be all you need for a test. I mean, it just might ask you how many 500 kc mils can you put in a EMT trade size 4. Then you simply go to this table, go over there, boom, that's the answer. A lot of times people will also overthink an exam. Remember, if you're taking an exam for your license, whether it's a journeyman's or master's or whatever, depending on what state you're in, just answer the question. Don't overanalyze it, because sometimes you can analysis paralysis. I mean, you can look at it too hard. And remember that all they asked you was how many conductors I could put in this trade size raceway of this type of conductor. And that was simply the answer. And you overanalyzed it. Okay. So don't overanalyze it. But what if I have different size conductors? Okay. Then I'm going to use the tables that are in Chapter 9. Now, the 2 tables that you're going to use extensively, okay, is Table 4. Now, Table 4 is going to tell you for each individual type of conduit or tubing that's under Table 4, you're going to have multiple columns. Now, those columns will tell you what the square inch value that I can have in that raceway that's not over 40, 53, 31. It's also going to tell you the nominal interior diameter in inches. And it's going to tell you the total area inside of that raceway or that conduit or tubing system based on square inches. Now, that's what you're going to remember. So while it does give you millimeter squares, it gives you square inches. You want to remember, make your life easy, use the square inch values. Now, in Table 4, let's work off that same EMT. So that EMT, if I have more than 2 wires in that that conduit or tubing. Then I go over here and you'll notice that it starts at a half trade size. Many people refer to that as inch, but it's really called trade size. I don't think anybody's going to yell at you for using inch the same way we're not going to yell at you for using sub panel when it's really not a sub panel in a house, for example. It's a remote distribution panel, but everybody knows what we're talking about. So there's those technical code Nazis out there who will really ream you if you use a sub panel. But you know what? Hey, we're real here, man. We don't play those games. So from a trade size half all the way up to a 4, it'll tell you what the square inches are that you can exceed to not exceed that 40% fill. Pretty simple, right? So table 4 gives you all those values. For example, if I was going to put a non-metallic sheath cable, an NMB, inside of a EMT that's connected to 2 boxes for whatever reason I wanted to do it, I'm allowed to do it, then that would be considered 1 wire, okay, by virtue of Chapter 9, Table 1, Note 9, and I could use a 53%, so I come over to the 53% column as 1 wire. I treat it as 1 wire, and then I come down and I can find out what size, the minimum size, trade size conduit or tubing that I need for that application. Right. And again, you got to remember that you have to do a conversion in order to convert that elliptical into a round type of cable assembly or wire. And again, we have I have a blog that explains how to do that on our website or on my LinkedIn page. And you can get to my LinkedIn from the links on masterthenec.com. Shameless plug for you there. So that's how you do that. Now, you do have a bunch of these tables because they deal with ENT, FMC, and they all work the same way. Now, what about if I have a raceway that's a short raceway? Let's say it's very small. It's considered a nipple, under 24 inches or 24 inches or less. Then the fill requirement would be adequate under the 60% fill. Because the code says you can't exceed more than 60% for nipples and short raceways like that. So 60%. And again, we're not talking about the pieces for protection. You're allowed to exclude that under Chapter 9, Table 1, Note 2. We'd already talked about that. If I have a nipple, let's say a distance that's 24 inches or less between 2 boxes, then I can't exceed more than 60%. And so in that application, I'm going to use the 60-degree column. All right. So that's what Table 4 is for, to give you that. Somebody also asked me, where did I get the 60% requirement? That is in Chapter 9, Table 1, Note 4, which says where conduit or tubing nipples have a maximum length not exceeding 24, so that's not exceeding 24, so 24 inches or less, are installed between boxes, cabinets, or similar enclosures, the nipple shall be permitted to be filled to 60% of their total cross-sectional area. And again, that cross-sectional area is listed in Table 4 of Chapter 9, but you already have a column for 60, so that kind of gives you a cheat sheet there. Also, it does remind you that the adjustment factors need not apply for this section, for this condition. In other words, if you take my video class on 31015B and you'll talk about 31015B3A, then when you have to do an adjustment, then you don't have to apply that under this rule for that that little piece. Okay. So that just kind of gives you it just tells you in there that you don't have to worry about that. And that is, again, for the number of conductors that are in that nipple, because you're going to kind of take care of that by not exceeding the 60%. So they kind of take care of each other. Now, remember, as always, you might have an ambient type of correction. Okay. And if that correction has to take place, then you still have to account for the ambient temperature in adjustment and corrections. But again, you need to go watch that video if you're not understanding what I said there. All right, but that's where we get the 60%. And again, that is in table 4 of Chapter 9. Okay, so let's go back. So that's what you get for that. The next important table you're going to need is Table 5. Now, Table 5 is the table that actually gives you all the dimensions of insulated conductors and fixture wire. Now, these are all of the insulated conductors that are permitted to be used inside of a building in accordance with the National Electrical Code in accordance also with 310. And so you're going to have the RHH, RHW, THHN, you're going to have XHHW-2, you're going to have all these wiring types, THW, all of that's going to be here. And these have generalized acceptable insulation thicknesses, and so you're able to use these values. Now, when you get to this table 5, you're going to have you have multiple columns. In fact, you're going to have 6 total columns. The first one is the type, which gives you the insulation type, so you got to know that. And if you're taking an exam, they're going to give you the type. Then it's going to be the size in American wire gauge or KC mil. So once you get to 250, that's one step above 4/0, or some people say 4/0. Then at that point, it gets into what we call KC mil. Now, a lot of people out there still call it MCM. That's the old standard. Now we call it KC mil. So 250 is 250,000 KC mil, or 250,000 circular mil. And when you get there, if that was your conductor sizes, then you go to the right and you're going to see approximate area, and then you're going to see approximate diameter. What you need to use is the approximate area. Remember what I said? You're going to use square inches for this because they correlate with what was in table 4. Now, when you go down here, you just simply, let's say I had that same math we did. Let's say I had 4 500 KC mil and they were all the same size. Well, I could go to Informative Annex C and go down. And as long as I had no other conductors, I could pull that and I'm okay. Because we're just really talking about, do I have enough area in that conduit or tubing to be able to not exceed the 40%? So I go down here and I write down, so I look for my 500 KC mil. Let's say there's 4 of them. Well, one of them has a square inch value of 0.7901. So I'm going to write that down, 0.7901. Now, since I had 4 of them in there, I'm going to do that value times 4. And then that's going to give me a total value. Okay, now that total value, and I'll do it for you since you don't, obviously this is a PaulCAST. And again, it's so conceited, isn't it? PaulCAST. I like it though. All right, so it's 0.7901 times 4 gives me a total approximate area of 3.1604. Now, since I know that value, and let's say we're doing it EMT, then I can go all the way back to my EMT size, and I'm going to show you how this works. And I go back to table 4, and I go for the EMT, which is Article 358, inside of table 4 of Chapter 9. And what I'm doing is, say I got 4, so it's over 2, so I can't exceed the 40%. So now I come down that column, and I want to find the next one that is larger than 3.1604. And I come down and I notice that a 2.5 trade size is 2.343. Well, that's not enough to handle my 3.1404. So I go to the next size. The next size, which is trade size 3, says it can handle 3.538 before it exceeds the 40%. Well, I only needed 3.1604. So that's my answer. So trade size 3 of EMT can handle 4 500 KC mils of THHN. Now, correlate that with the informative annex and see how it works out. So let's go to that and see what it says here. So I'm going to scroll down to the EMT just to check our math and look for THHN. And I found it. And it's 500 KC mil. And then I'm going to follow it over. And it says that actually I can get up to 5 in there per this if they were all the same size, right? and not have a problem. The reason it doesn't go higher is because I can put that is the minimum size, because a 2.5 trade size will only allow 3. So you see how this will actually round it up for you because they're all the same size, and you have that allowance to do that inside of Chapter 9. Table 1 in one of the notes that give you that. And we don't want to get into the complexity of that. I just want you to compare the two. So if they're all the same size, I can use Informative Annex C, or if I want to get a more precise value, then I can go and use Chapter 9, Tables 4 and Table 5 to pull this value. Now, the reason I'm going to use Chapter 9, Table 4 and Table 5 because I don't always have the situation where I'm going to be able to have all of the same conductor size inside of my Raceway. I'm going to have a smaller neutral, or I'm going to have a smaller equipment ground, or I'm going to have whatever. And, I have to take all these type of things when I'm doing the actual fill into account. So let's go back to Chapter 9, Table 1 again. Now, let's talk about that equipment grounding or bonding conductor. It says, in Note 3 says, where installed shall be included when calculating conduit and tubing fill. Okay. Now, you might not do that when you're counting. You don't do that when you're dealing 31015 B3A, when you're dealing with the adjustments, and you don't have to worry about the application there, because we're talking about current carrying conductors. Here, you're talking about fill. So that's where it comes into play. So keeping that in mind. So that's how you do that. No, so the next thing that we want to kick in, we want to talk about is dealing. Oh, wait a minute. No, that's good. All right. So next thing we want to talk about is Table 5A. Now, what this means. So you're pretty good about Table 4. You kind of get a dimensional requirement for Table 5. Well, what happens if I'm using a compact copper or aluminum? Now, I can tell you compact aluminum is more prevalent than compact copper. Usually copper is concentric lay. It might be compressed where you get some of those little interstices. That's the little gaps around each individual conductor in a bunch. When you got something that is compact, you're actually compressing it to the point where it goes past normal compression and it goes into a compact state. And there is really no interstice in there. And so it kind of makes a trapezoid shape. It's more difficult with copper because it's a harder material to compact, but it is available in both. Most manufacturers are going to give you the actual compact aluminum. And you can tell it's compact because if you look at the end of it, you really don't have a bunch of these little openings or little grooves that are called interstices. And so really, if you get rid of those, then what does that tell you? That the actual conductor is less size. Although it might have the same total area, it's less size overall. And since we're talking about the approximate area, it takes into account the different insulation thicknesses and everything into making an adjustment. So the conductive material might not be theoretically different, but the overall footprint of the approximate area is different. Forget all that. What I just told you, if it confuses you, just do this. It is technically going to be a smaller physical presence in the Raceway. So if it is compact, I get to use Table 5A. Now in Table 5A, it really applies to RHH, RHW, or USC. It applies to, there is a bare requirement in there for bare conductors that are in there. It also, because bare conductors you can treat as compact. You have type THW or THHW. You also have THHN and XHHW. I will tell you that the THHN can be conversely used as THWN-2 because that product is the same. So that's what we're doing with this application. And all of these dimensions really come from industry standard sources. And that's part of the UL standards for the production of these products. So that's where the information really comes from, right? All right. So we're all good here. And that's your nominal dimension. Now, in here, you do the same thing. So if I was dealing with 500 kc mil compact aluminum, I wouldn't use Table 5. I would, the normal Table 5, I would go to 5A. And then under 5A, I look for 500 and I follow it across to the different type of insulation that I'm using. In this case, we were using THHN/THWN-2. And in this case here, the square inch value for that is 0.651. Now that is different than what we got for 500, for a 500 kc mil. So that was 0.6151. And the other that we did was, let me make sure I'm on the right one. Yeah. So the other one was, for 500, was 0.7071. So from 0.7071, we're able to go down and get a smaller footprint, if you will, to 0.6151. That can make a huge difference when you find out that it could push you, if you use regular THHN, that it could push you into a larger conduit or tubing. Whereas if you used a compact, you might be able to get into that smaller trade size conduit or tubing. So that's the benefit. You can use this compact when you indeed have compact conductors. All right. Anyway, that's about it. So look for a video to come out soon where we'll have a bunch of examples and work the different examples. We're going to have box fill calculation videos coming out to get you familiar with those. That's a little more complicated to do in a PaulCAST or a podcast. So at the end of the day, I just want to give you the tables that you're going to use. And those are the more predominant ones. So what's a summary, a takeaway? If you need to know what the percentage of fill that you can't exceed, you're going to use table 1 of chapter 9. If you're going to put a cable in a complete conduit or raceway system, then you need to know you can, if it's one cable, you treat it as one and it doesn't exceed 53% fill, and that's chapter 9, table 1, note 9. If you're using a conduit or tubing for physical protection, it's not complete, then you don't have to worry about the fill requirement. Again, if you're using an MC or something like that, then if you're putting it in a conduit, then if you're just putting one in there, then you can't exceed the 53%. You treat it as a single wire. An MC cable or a tray cable in itself doesn't have an approximate area total to worry about because the conductor's already in there, so don't worry about that. When you're taking the conductors you're going to use, if they're all the same, then you're going to use what's called Informative Annex C, keeping in mind that that's only telling you the number of conductors you can put in there. If I have to make an adjustment or correction due to ambience, temperatures, or an adjustment due to the number of conductors that are in the that are in the conduit or tubing, then this might not work. I have to take that into account because Informative Annex C doesn't account for all that. It's simply purely how many conductors can I put in this raceway? And you need to keep that in mind when you're doing that, especially for an exam. Answer the question just what they ask you. That's it. Don't make it overcomplicated. If you have compact conductors, then you can use table 5A and you just and do it there. If you're doing different types of conductors and they're not compact, then you're using table 5 and you just look up the conductor and you write that square inch value down. If it's 4 of the same size, you do that value times 4. And then if there's another, say, equipment ground with it, say in a PVC conduit, then all you do then is look up what type of wire is the ground is, whether it's insulated ground, if that's also THHN, you just find that size and you go over and you take that approximate area as well, approximate square inch value, add the two together, then go to the chapter 4 for whatever type of conduit or tubing you're using, and then find out under which column you're in. May it's over two conductors, then you'll be in the 40%, and then go down and find out what tray size conduit or tubing you need, and you're done. Then, once that's done, then you got to look at your adjustment and corrections, and that might change your size of your conductors, and then you got to redo that all over again. But that's kind of how you do it, and that's the kind of the prep before you get into our how to do raceway fill calculations and whatnot. So, hopefully you got something out of that. Again, my name is Paul, and hopefully if you got any questions, feel free to email me at info at masterthenec.com. That's masterthenec.com, just like it sounds, masterthenec.com. You can also get there at electricalcodeacademy.com, .net, or .org. But if you want to email me, it's info at electricalcodeacademy.com. You can only do the emails to the comms, not to the nets or orgs or whatever. Keep that in mind. Go to our Facebook page. You can get there from our websites, or go to Facebook and search for Master the NEC. You can also get there our Twitter account, which is at Master the NEC. You can get all of these things from our website as well. And go to our Facebook page. Again, search for Master the NEC. If you have any questions, feel free to email us. We have a lot of video content on our website. We have a lot of our podcasts, I like to call PaulCasts, available for listening on Spreaker, on the website itself, even on YouTube. If you want to just listen via YouTube app on your phone, you can still listen to our our PaulCasts or podcasts. Okay. Anyway, God bless. Take care. And remember, Happy New Year. If you have any questions, get in touch with us. We'll be glad to answer those questions for you. Take care.